Hello everyone and welcome back to Stationeers. Okay then, so in the last episode we managed to sort out oxygen storage and the jetpack refill, and yes, by the way, I did notice that I put a pressure regulator on the jetpack refill when it should have been a back pressure regulator, but because of the way the code works, it will basically still act as a back pressure regulator. In fact, I still need to set the limit on the oxygen storage, so we need to go out anyways, so I might as well show you. So you and you come with me and cycle, and we are going outside. So technically speaking, everything is working as intended. It's just a little bit, not quite as I would have liked. So the code will still only turn this guy on if the pressure in here is above 7500 kilopascals, and well, this is a pressure regulator and it is set to way higher than the atmospheric pressure, so it will still, keep this one at the correct pressures. So I will not change it. I don't want to mess around with renaming and resetting the pins. It's fine. But I did not set this one correctly. In fact, I didn't set it at all. It is the correct kind of regulator. It is a back pressure regulator, but it is not set to the correct pressure. So this one should be, I believe it was 55,000. I think so. Basically, I just don't want to have more than 55 megapascals of pressure in the storage tank. Other than that, I think this is okay. I mean, okay, technically speaking, this would have also worked because this guy will only turn on the pressure regulator if the pressure in here is, above 5500 and the limit was set to very, very low. So it still would have done the job, but you know what? Might as well do it properly. Anyways, now that we have that out of the way, let's just go inside and let's see what we can do about water generation. That is going to be our next big project. So for this one, we need to strip down because we might need to go through a couple of stuff. So I think I will build the water generation right here. It is a relatively big open space. Because of the black holes going to be always cresting over there, we are not going to block the solar panels, so that's fine. Okay, so what do we need? We will definitely need to have some atmospheric skids. So right now this is empty. Let's just put everything together so we can take stock of our different resources. This is, I believe, empty. It is, good. And this one is empty. Everything else is in the electric sprinter. So please empty this one out. Other than that, I think we have everything okay. So all of you, please go inside and start printing what we need. You can close and turn off. So as I've said, we will definitely need to have some atmospheric skids, Atmo, and tell you what, today I will only sort out the actual water generation, and I will worry about the actual cooling of the water afterwards. Maybe we'll get started on that today, but I am not sure. Basically, the problem is that I have discovered a limitation on the, the AC units, for example, this guy. We have something called the operational temperature efficiency. Well, as I have said previously, these units cannot really use hot coolant to cool down the target gases, but that also works the other way around. We cannot really cool down super hot gases very efficiently. It will work, but super slowly. So what we need to do is basically try to keep the two temperatures relatively close together, maybe a couple hundreds at max. Basically, the problem we are facing right now is that the water and the waste gases that will come out of the H2 combustor will be super hot. and I really mean super hot. It's going to be, it will start at 2500 Celsius. 2500. That's a lot. So yeah, we need to cool that one down. Yeah. Okay, so we definitely need to have a platform. You can go in the tool belt. We will need... Okay, we will not need mining. So I think I will leave it here for now. Right. I want to have as much space in the inventory as possible. So, next up. We will definitely need to have... well, might as well go to what we actually need. We will definitely need an H2 combustor. This guy will take a combustible mix of oxygen and volatiles. For the purposes of this reaction, volatiles will mostly, not completely, but mostly act as hydrogen. So we will need to have a 1 part oxygen and 2 part volatiles to make it as efficient as possible. So 33% oxygen and 66% volatiles. Thankfully, we have a mixer, there we go, a gas mixer. Might as well print it out now. That is what will take care of the mixing of the gases. Obviously, the oxygen will come from the oxygen storage right there, and we will have one of these atmospheric units act as a filtration for the volatiles. I'll just do this locally and preferably at night, because you come with us. I would like to take in volatiles at night, because obviously it will not make a single bit of difference in the H2 combustor, but at the nighttime temperatures, volatiles are not combustible temperatures. I don't know the exact temperature that we need to actually ignite, but it will be mixable basically, and that is super important. So we will need to only harvest at night. And then we will need one more filtration unit, which will filter off the water from the rest of the waste gases, because as I've said, volatiles are not clean hydrogen. They also contain a lot of secondary combustible materials, and apart from water, we will also get, I believe, CO2 and pollutants. So we need to get rid of them, and we will filter off the clean water. Well, okay, not water, it's going to be steam. Because obviously, as I said, it's going to be super hot. Okay then, so we have the atmospheric kits, we have a mixing, then we will definitely need to have a bunch of utility kits. So we will need to have one big tank for the volatiles filter, sorry, 2 big tanks, because one for the input, one for the unfiltered output, and we will need one more for the water filtration, because we need to get rid of the extra gases. Although I think for the exhaust, we don't really need it. Okay, I will only print out 2. If we are being limited, I mean, for this one, we don't really need to go fast. Slow will do it. Yeah, okay, I will only print out 2. But that will do. On the first filtration for the volatiles, we also want to have a small buffer on the output, on the filtered output. So I think, and obviously preferably it should be insulated, so let's just make a insulated inline tank. Right, and then we need a lot of pipes. Some of these will be regular pipes, but most of them will be insulated. We need to have insulated on the output of the volatiles, on the mixing, because obviously we don't want to heat up in the midday sun, and then on the output for the filtration. Although, no, it needs to be insulated, because, well, in the summer months it's going to be above 1000 degrees outside, so we don't want 1000 degrees steam. Anyways, this one goes in there, and I completely forgot that I didn't break this one open. So I did place another window there, right? Yes. Okay, let's just quickly get rid of this, and there we go. I should have done this a long time ago, but better late than never. Next up. As I said, I think I will start with just the actual water generation. I will worry about cooling it down later. So let's just make a small platform for this. Empty out and just give me the steel. No, 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 and yes. So yeah, let's just create a 2x2 platform. That's going to be enough. So give me a couple of steel frames. We already have the sheets. You can continue creating regular pipes, I think. So just give me pipes and these guys. As for you, one more please. We have plenty of sheets, so you don't need to worry about that one. Okay, in fact, I think at this point you can empty out. Okay, and turn off, and you can go back in here. Okay, let me see. I think this should be enough. Yeah, sure, enough. At least for now. Then we definitely need to have some cowls. Sure. Search for it and cowl. So we need at least 3 of them. 1 for the voltage input and 2 for the outputs of the filtration. So 3 of these. What else? I think that's pretty much it for now, at least. So that's it. And after this, can you please give me a lot of insulated pipes? Okay, we don't have enough room in the inventory. Okay, I will drop the insulated pipe for now. You can go there, and you guys come with us. And alright, silicon there, and you get to work.
Hunger critical.
Okay, I will eat real quick. Eat and drink, obviously. And I will put 1 more potato in the microwave. So I will quickly go outside, weld up the foundations at, well, 1 time at least, and then we'll hop back inside and take care of the pipes. We don't want to overprint, but we want to have a lot of them. So there you go, you cook, and let's suit up and we can go outside. So, as I said, we will start with the foundations, and it will be right here. Right, I think this will do for now. Okay, let's go inside and pick up our stuff. I think I have some idea of how I want to lay this out. I think I would like to have them... Well, first things first, you can go on the shelf. And I think this should be enough, right? Well, if not, we can print more, but I think this might be enough. And 1 more, and that's it. Right? Yeah. So, what... I mean, I suppose I might as well show you when we are outside. By the way, how are we doing on the voltage filtering for the trade? If we have enough, we might as well trade now. So you go there. We have... I believe I set the limit to 30 megapascals. So I think maybe in the morning we will have enough. So that's fine. So let's go ahead and lay down the machines first. And there we go. Oh, and we need to be careful. We have a lava river right under us. So, let's take a look. Let's start with the voltage filter. I think I will have it here. So filtration and facing this way. Basically, we will go from here to here to here, and we will have the cooling setup here, hopefully. So anyways, filtration. I think you can be right there. Yeah, that will leave us enough space for the cabling. And then you will be the H2 combustor, like this, and you will be facing this way, exactly. Right, we need to leave a bit of space, so this looks correct to me. Right, you can come with us now. And you will be the filtration for the water. So you will have your input there and gas output there, so I think this should be okay. There. Right. Okay, let's start putting things together. So here we need to increase the volume of the input. So let's just go ahead and put this inline tank here. Yeah. Okay then, so you go into the tank and we have a cowl right on top. And then I don't think we need a lot of output for the exhaust, so let's just do this. Hopefully it's going to be okay. If not, we can increase it later. Same goes for you. This is the unfiltered output, so this one can be like this. That's fine. And then the mixer, I think, yeah, right here. And okay, I will just take a peek inside, and I was afraid of this. Okay, you need to move out one more. Okay, thankfully it's okay. Let me just quickly pick you up. You need to be here instead, so we have enough room for the different pipes. So H2 combustor that way. And in that case, yeah, might as well line everything up. Let's make things look nice. So pick up everything. Okay, so the mixing unit. I think I will put this guy here. Right, I don't think we can have them immediately in front of the input. So it will have to be here. Which means that we will need to have this extra storage for the volatiles standing upright like the other ones. So you will be right here. That's fine. Okay then, so first is first, let's hook these guys up. And you will get your oxygen from this direction. Well, eventually. Obviously not right now. Then you will feed the combusted gases and, yeah, basically gases because steam is a gas. You will go into the filter right here. Obviously this will get an H2O, set of H2O filters, set of volatile filters, and right, this one also needs to be right there, and yeah, I think this will do. Okay, let's see, might as well put in the pipes now, there and there, and the cabling. I believe we need the screwdriver for this. Yes. That's good enough. Okay, so this will filter off the water. For now, I think I will just have a utility kit to store the water. Then we will worry about the rest later. In fact, maybe I will just move this canister holder outside. Yeah, I think that might be the easiest way of doing this. Okay, quickly before we cook, because our waste tank is filling up. Okay, we open the waste tank, switch out the oxygen, and let's see what's next. So, let me see, we will need a lot of cabling for this. And yeah, I think I will move this guy outside. Okay. You come with us, and we need the hand drill, right? No, we need the wrench. Be very, very careful. Don't want to break that one open. Oh, never mind, crowbar. Okay, it's fine. So you go there, and I don't think we can attach the canister holder immediately on the input, sorry, the output. So this one needs to, I think this will give us only 2, right? No, 3, okay. There we go. Now we have 1 extra inserted pipe, so that's fine. Anything else? No, I think we just need the wiring. And a lot of pipes for the oxygen. Right, I don't think 16 is going to be enough for this. Yeah, first things first. Keep printing this one, and the copper, you will give us the cabling. Oh, and we are running low on copper actually. I might need to go out and mine a bit in this episode. I am not sure yet. Anyways, we have 1 stack. I think maybe 1.5 stack should be enough. Yeah, I think so. As for the cooling, I think I will actually go for phase change. Now, the problem with phase change is that that one also has that temperature differential problem that the AC units have. So we will not be able to cool everything down to 20 degrees Celsius with basically even nighttime atmosphere. But you know what? It's better than nothing. Basically, if you can input even, I don't know, 60 degree water into the base, that's fine. I will just have some radiators on these lines, and we will just cool it the rest of the way that way. It should be fine. Also, by the way, the cabling is okay, no half grams. Well, are we ready to go? Yes, I think so. Oh, right. What is the state of our power network? Let me take a look. So you switch this one out. Let's take a look. Ooh. 7 megawatts potential. Oh, that's a problem. I don't think we are in danger of actually reaching that potential. But the fact that it is a possibility is a big problem. I believe these cables are only capable of handling 5 kilowatts. Above that, they will burn out. Also, you can turn off don't waste energy, although we are very much okay on energy at this point. But okay, you know what? At some point we might want to start separating out different parts of the network and have a central high voltage cable running through the base and split off that. Right. Okay. To prepare for that, we might as well make a transformer now. So I believe we need this one and iron, I believe. No, not steel, iron. So can you please give me a transformer? Small one will do, and yes. Iron, gold, copper. Okay, just the one. No need for more. We only want to limit this to 5 kilowatts. That's going to be enough. And in this direction, please. Yeah, sure. You can go here. Okay. We don't need to take out the labeler for this. We can just quickly click through it. And I am not sure if this will actually manage to limit the throughput correctly. So you know what? Just to make it extra safe, let's just go one step down. 4990 watts, and that's it. Okay, you can turn on now and you can be hooked up. Okay, and I think we can go outside and start wiring things up. And by the way, we are in midday. Not the best time, but we have plenty of waste storage now, so it's fine. Okay, let's do it. And I think I will go that way first, so we can hook up the oxygen as well. So, oxygen. Let me see. What about a nice long 10 pipe? Oh, okay, be very careful. Don't fall into the lava. That was close. Okay, apparently we can place this one here, so there is nothing in the way. Okay, that makes it a bit easier, and we can save on pipes as well. So, let's just go ahead and hook these together. There and there. And how many we need? We need to split off from here for sure. Okay, let me... You drop it, you pick up. Let's make it correctly. With nice white piping. Okay, so oxygen pipe is in place. Very good. Well, in that case, all we need to do now is start wiring things up. Okay, let's get to work. So, is everything hooked up? Oh, wait, never mind. This one is still not hooked up. I think the easiest way to do this is... I think through this way. Yeah, I want to stay as close down as possible. Let's just go this way. Okay, now everything should be hooked up. And just to be on the safe side, you set to flatten and maybe carve down the leveling a little bit like this. Oh, and we have some copper. We might want to dig that up. But first, let's make sure everything is visible. Okay, don't get carried away. So, this platform is now good to go. Yeah, right, apart from the actual water storage. So, for now, you just go there. The canister holder will go right there with the canister, obviously. Okay. Now we just need the filters, I believe. Alright, and this one needs to be set correctly. Right now it is a 50-50 mix, but as I said, we need double as many voltiles as oxygen, or double as much. And this is the input 2 and input 1. Okay, so we need input 2 to be 60% or 66%. 67. We might want to have a tiny bit more voltiles than oxygen. Okay then, so since there is nothing in this pipe, if I turn this on, nothing should come through. So let's just make sure. Network analyzer, that's not what we need. But anyways, I think if one of the gases are not present, the mixing will not happen. Okay then, let's print out the filters and I think we can start making some water. So first things first, you switch out the cartridge and then you are on. You have the voltage set or wattage, and I think that's it for now. Right, okay, let's move the filters. So we need voltiles and water filtering. Invar might as well go for medium so they will last a bit longer. Then wait, no, not steel. We need silver. there, and the iron. So, can you please give me a volatile medium filter? Oh, sorry, constant and not invar. There you are. Okay, so 2 of these, and after that 2 for water, and I think we are pretty much good to go. Now, obviously, for the first time, I will do the first run manually. We do not want to leave it up to the, automation before I know exactly what needs to be done. Right. Okay, so that's the 2, and yeah, 2 medium water filters, please. So you guys come with us. And then you. And I think that's all we need. In fact, if I really wanted to, I could bring a tiny bit of water in with this canister, and a tiny bit of water will not heat up the base all that much. But you know what? No. This is just a proof of concept test run. But as far as I can tell, it should work. Okay, let me quickly drink some water so we stop the heavy breathing. There we go, and let's go outside. By the way, how are we on the volatiles? I think we are close enough to the 30 megapascals, so I think I will sell this now. So put all the gases in, and please buy it. So 14 and 4 more, and that's it. Okay, pause for a second. You stop inputting and put everything out again, so it doesn't heat up in the midday sun. And you, can you please give us, how much water can you give us? 10 more liters, not bad. Yes, please. Okay then. Yeah, the gases are on site, so you can turn off. So, let me see. Let's put in the filters and let's see what we are dealing with. So, volatile filters go in here and water filters go in here. So that is the unfiltered, that is correct. That is the unfiltered, that is correct. Okay then. So, as I said, if I turn this on, nothing should happen in this pipe. Correct. Okay. It will only mix if both sides have enough gases. So, let's start building up some volatiles. I think automating this one should be fairly easy. We just check the input pipe temperature and the output pressure. If this is low enough and this is low enough, just go out of idle. And it is building up, you know what, fast enough for our purposes. It's okay. Okay, you can turn off now because we don't want too hot gases for this. I think 156 it should still be okay. So let's mix the gases in here. And there we go. We have a combustible mix of volatiles and oxygen. It appears that... Oh, right. It is not going by raw mole values. It is going by, well, actual volume or pressure. So it is inputting more oxygen because it is lower temperature, so we have more moles in the same amount of pressure. That's not great, but not too bad. Okay, anyways, we have 12 megapascals of, yeah, combustible mix. So if I turn this guy on, we should have all the waste gases plus steam. Let's take a look, and there we go. And take a look at the temperature. Over 2000, 2300. That is a lot. Anyways, I will Yeah, we can take the pressure on this one, it's fine. Let's just use up all the gases from this pipe. And that will do. You can... It's okay. Alright, it is equalizing, not pumping it out. Okay then. So now we have this one. How much water, by the way? 6 moles. Plus 10 more moles in here, so 16 moles altogether. I think this one will be able to take it. So next up, you are off now. No, wait. You need to be on to actually output. So let's take a look. Pipe network. Oh, right. It already had some water inside, so that's fine. So let's start filtering it in. Sorry? What's your problem? Flashing an error. Why? Oh, okay, I know. We obviously put a liquid pipe where we need to have a gas pipe. Okay then, so we need to have a condensation valve. I completely forgot about that one. Well, in that case... I don't want to overpressurize this. Although I don't think we are in danger of that. Okay, let me quickly make one valve. So, give me a valve kit. For that we need copper. And yeah, we definitely need to go out and mine for some copper. Anyways, one of these and a pipe. And we have those on the inventory. Okay, so one of these. This is where this guy will come in, the condensation valve. Basically what this guy does is it will skim off any liquid in a gas pipe and basically put it into a liquid pipe. But only the liquids, nothing else. So basically if anything condenses out in the output pipe, the liquids will be pushed into that storage. At least theoretically. Okay, let's take a look. So, first things we pick this one up, so we will push the water back into the canister. There, and you come with us. Although it is basically no amount of water, but still. And yeah, this is completely empty now. Okay, so you can pick this one up as well. So first, we need a gas pipe. It is off, good. So you will go there, and then the condensation pipe goes there, exactly. Might as well open it now, it's fine. And then, you know, I think for this one we don't need another piece of pipe. I think this one can go a direct connection. Right? Maybe not. I was kind of hoping. Okay, this is placeholder anyways, so let's just move them correct to another position. Okay, so I am fairly certain that there will be no condensation here because it's going to be superheat steam, but still, maybe we get lucky, I don't know. So let's keep an eye on this. So now everything should be okay. So turn on, keep an eye on that pipe network. And there we go. And you turn on. And there we go. We are filtering off only the steam. Everything else is being shoved out of this pipe. Thankfully, the remaining oxygen is not high concentration enough to set off the ignition, so it appears to be okay. And at the very end, we should have about 16 moles of liquid, water. And yeah, that appears to be the case. And this one should be empty now. Not quite, now it's empty. Oh, right, and this is also equalizing with the output pipe. So this is now empty, you can turn off. And this is empty now, which means you can turn off as well. So we have 16.1 moles of water. But yeah, it is 1200 degrees Celsius. That is not ideal. So how are we going to pull this off?
Waste tank caution.
Okay, time to go inside and... you know what, no. Let's switch out the tank and mine a bit of copper now, while we can actually see where everything is. There's some copper there, maybe there, but let's mine some because I suspect we will need some copper for what I have planned. So let's go for that. Okay, surely 7 stacks of copper will keep us going for at least a little bit longer. Okay, so I think we don't need to worry about copper for at least a couple more episodes. Okay, hunger, it's fine. I think we can smelt now if you are quick about this. So first things first. Yeah, we need to start outgassing. Okay, you turn on. By the way, how are we on the hot gases these days? Temperature is okay, and 13 megapascals, not bad. Okay, just put in, sorry, not output, put in please. And okay, I think that should be enough to process most of these. Okay, it is too cold now, so we need to vent out, which means you turn on, empty out the cold gases from the furnace, every single little bit, and then you put just enough hot gases inside to smelt the copper. And that will be nice. Okay, I think maybe 100 kilopascals should be acceptable. Yeah, sure. First, the pump on the furnace and then the turbo pump. In fact, I really should automate this one, so if we have anything on the output, you should turn on basically. Anyways, just a small trickle and that will do. Okay, we have copper and we have barely any gases inside, so I will leave you as you are right now. Okay then, let's go inside. So, phase change. Let me see if I can at least try to explain how this works, because this is a bit of a complicated topic. Let's just put everything inside. I don't think we need astroloid, but let's consolidate everything. This one is empty and empty. Okay, so everything is now in here, right? Yes. Okay, you turn on. Can you please give me a phase change device? Huh, it's cheaper than I expected. Also, ooh, silicon. Okay, so we need some silicon as well. Good to know. But yeah, we needed copper for this one. Okay then, so one of these. Oh, I can only hope that I can explain this because it is a complicated topic. For this one, we will need an evaporation chamber. So you will go here for now, and I will put this together right now. Thankfully, we can weld because we have the arc welder. So we need first the wrench and then the arc welder. There we go. And this is a phase change device. Okay, then how am I going to explain this? Basically, there are two kinds of phase change devices: an evaporation chamber and a condensation chamber. And you know what? Oh, okay, power. Give me a second, please. lamp and you, and there we go. So we might as well bring up the phase change diagrams. You just need to know that we have one gas output here, a liquid input here, and a gas, basically a heat exchange right here. So it has three connections, two gas and one liquid. So let's bring up the pollutant phase change diagram and pause the game. Okay, can I make this one? I think it should be relatively visible still, so I think it's okay. Okay, this is the phase change diagram. This looks a bit complicated, but once you know what is what, it should be fairly self-explanatory. I will switch to Celsius mode because, well, it's going to be a bit easier. We don't need to convert between Celsius and Kelvin. So, we have three phases of matter in this game: solid, liquid, and gas. And we have these lines right here. This is where the actual phase change will happen. So, for example, let's say we have a pollutant atmosphere that is 3600 kilopascals. Sure. So, that means that in that specific atmosphere, if we go higher temperature than 20 degrees Celsius, then the pollutant will start evaporating. But if it goes below 20 degrees Celsius, then it will start condensing out. So this is where the phase change between gas and liquid happens. Higher temperatures means gases, lower temperatures mean liquids. So we can also go and use this one to reach a certain temperature as well. Let's say we put in liquid pollutants in the intake pipe right down here. And we set a certain pressure with this valve right here. Let's say we set exactly the target temperature of, I believe it was 3600, yes. 3600, thereabouts. Yeah, sure, here. So, let's say we set a pressure of 3600 kilopascals. And, well, that will mean that if the temperature inside that chamber is above 20 degrees Celsius, then the liquid pollutant will start evaporating, and this phase change will actually steal heat energy from its surroundings. So it will basically cool down the surrounding gases in the chamber. And we also have this heat exchange pipe. This is where the chamber will steal heat energy from. So, as you might have guessed, this is where we will hook up our water supply. But if we hook this one up here, this is not directly connected to the condensation chamber. It is basically just a heat exchanging kind of interaction. So this pipe right here is only connected with a heat exchanger, so it will not evaporate or anything like that. It's fine. And then we have this gas output pipe. This is basically where the evaporated pollutants will be vented out. It's fine. We don't need to worry about this one. It just needs to go back into the atmosphere, at least for this application. So, as I've said, we set a 3600 kilopascals worth of pressure in the evaporation chamber, and we'll start feeding this with liquid pollutants. Now, we will only be able to feed this one with hot 127 degrees of liquid pollutant, which also means that yes, we will encounter some inefficiencies as we go down and down in the target temperatures. I believe we will be able to reach about 50 or 60 degrees Celsius or thereabouts. But the important thing is that basically this is a very power efficient way of, well, dealing with cooling. All it will do basically is, well, put liquid pollutant in here, and then it will steal heat energy from this heat exchange pipe. It will keep the temperature in the evaporation chamber hot enough, that evaporation will keep happening, and evaporation will steal heat energy from the surroundings, which means this pipe. And then the gas pollutants will be vented out. And if for whatever reason the chamber ever reaches 20 degrees Celsius, then it will basically reach an equilibrium, which means that no evaporation or condensation will happen, and well, we will have reached our target temperature at that point. And I can only hope that this was understandable. Now, for this application, we will use this dedicated machine, but for the main base, I think I will try to put this whole system together without using these chambers and use pipes and condensation valves and purge valves and all that kind of stuff. So I will try to set up a manual version of this. And I can only hope that we will manage, but you know, it should be a nice challenge. Anyways, let's break this guy down now. So we need the angle grinder. Okay then. Well, before we go out, might as well eat and drink. And, well, you know what? No, I think I will leave this one for the next episode. I think I would like to take care of at least a little bit of automation for this, what we have built so far. So, for that, obviously, we need some of this stuff in here. So we definitely need to have the solder, I believe, and the electrum. Ooh, electrum is running real low. I don't think we have enough electrum. We might have enough for one chip. We have enough for two. Okay, so that was gold and steel. Okay. So gold and steel. Steel is not looking too rosy either, but it's okay, we have enough for two. So we can automate the voltage filtering and the H2 combustor, I think. Right, let's do it. So, these are on separate networks. What do we need for a laptop? Yeah, we need more electrum. If I make a laptop now, we don't have enough to make both chips. Okay, I think I will program them now. So you go in there. We need the programming IC housing. It is empty. Good. Okay, so as I said, the voltage filtering should be relatively easy. Let me quickly take care of that. Okay, one of the basic scripts. So at the start we will load the input temperature, the output pressure. If the input temperature is below 140 degrees Celsius, then it will be set to 1. If the output pressure is less than 25 megapascals, it will be set to 1. If both of them are 1, then it will be turning on the filtration unit. If any of them are 0, it will be set to off or idle, and that's it. Pretty basic. Okay, yeah, at this point I am actually recycling registers. It should still be relatively readable. Okay, so programming housing you can export to this one, and you will be here for the filtration, and you are done. So we need to go out and what do we need exactly? We need electrum and silicon. Right. Now this one is going to be a bit more complicated. So what we need to do is operate the mixture as well, right? And then can the mixer valve or whatever it is read the input? So gas mixer. No, it cannot. Okay. Well, we might want to have a pipe analyzer in that case, because obviously yeah, for now I will not read it, but maybe at some point. Anyways, what we need to do is we will check the output pressure. If it is too high, then obviously don't do anything. It will go into idle, I believe. But if there is still pressure that we can put into the output pipe, then set to active. And if for whatever reason there is no more combustible gases inside, then we want to turn on the mixer maybe in 1 second intervals. So we only make a small sip of gas every time, not a lot. Let's see if I can make this one work. Okay, I will try to explain what I have until now. So we will load the output pressure, the input pressure, and the internal pressure of the combusting unit. So if the output pressure is less than 10 megapascals and the internal pressure is above 500 kilopascals, then if both of them are true, then the on-off will set the combustor's mode to that value. So, right. So this will determine whether or not the combustor is working or not. Right, now we need to determine how to operate the mixer. So we need to make sure that we actually have some gases on the input pipe. Okay, yeah, we don't want to overpressurize the input pipe, so I think if we leave it alone, it might do that, so we need to monitor that one as well. So that is where we have the pressure input. Okay, let me see if I can do this. Let me see if this one will work. So after we have determined whether or not the combustor will be turned on or not, then we will check what is the input pressure and what is the internal pressure. If the input pressure is less than 1 megapascal and the internal pressure is less than 1 megapascal, then, well, if both of them are 1, then that will turn on the mixer. So basically, we will fill up the internal pressure of the combustor to 1 megapascal, so we will have plenty of leeway on this one. but if this one is 10 megapascals, so the output is 10 megapascals, then the mixer will turn off and we will turn off the combustor will turn off, and since it is now idling, it will not be able to take in any more gases, and this should make sure that we are not overpressurizing the mixing pipe. Right. So this is only true if it is less than 1 megapascal. So I think this should work. At least fingers crossed. If not, I guess we will find out. Okay, confirm and export this code to the programming housing, and there we go. So this is for the voltage filtering, this is for the combustor. Okay, I will quickly take a sip of water to drink. There we go, and we are filling up the bins, very good. By the way, how are we on water? Oh, very nice, 30 liters. Love to see it. Okay then, let me just quickly vent out and switch out the oxygen as well. And let's see if we can automate the, well, at least the combustor and the voltage filtering. Okay, voltage filtering is too hot now, unfortunately, but I will put it inside. I am fairly certain that this will work, so we don't need to worry about this one. So this one goes here and you can turn on and you are now idle. That is correct. And by the way, what is the pressure? Okay, the limiting factor is the actual temperature outside. Now about you. You are a bit more complicated. So right now the pressure here is way too low. So in goes this one, and might as well name everything. So labeler, you are the combustor gas mixer. Good. You need to set the device, obviously. So we need the combustor gas mixer. So if I turn you on, you should fill this one up to 10 megapascals. And you should start, I think we should have enough voltage to make this work. So this one also should turn on. Exactly. Okay, so it did turn off at 1 megapascal, that's very good. But why are you not working? You are set to idle. I think the... Oh right, we need greater than... Okay, we need one more check to make sure that we are actually pressurizing the internals to at least... Although... Okay, I don't think we need a internal pressure check. Alright, we need to have the chip as well. I don't think we need an internal pressure check for the first to turn on the combustor. As long as the output pressure is low enough, I think the combustor should just turn on. I think that should be okay. So let's take a look. You go in there. Programming, import, that's correct. Okay, so I don't think we need this check. I put this here because I wanted to make sure that we have, you know, something to combust. But you know what? If this guy turns on, then it will siphon off the combustible gases from here anyways, and that will turn on the mixer. So I think this will be okay, I think. Right, confirm. Programming IC housing, export, and there we go. So now it should be a bit better. Let's take a look. So as I said, I think we should have enough combustible voltage to go around to make this work. By the way, is the filtering for the water off? It should be. It is, okay. So whatever goes in here will stay right here. So in goes the chip. The device 0 is still set. Let's take a look. So let's take a look. And it is idling. I know that at least the mixer works as intended, so that is a big relief. We are not going to overpressurize this one at least. But this is a problem. Okay, one more check. You turn off. Yeah, this is still the right code. So let me see. If the... Oh, right. We are checking this one. We don't need to check. We just need to make sure that this is set to 1. So in that case, we can use this here instead. Now it should be okay, right? As far as I can tell, it is okay now. So confirm, export. Basically, we're still checking whether or not the internal pressure was still true alongside the output pressure, but we only need to check the output pressure. So it should be okay. So there we go. In you go, and let's take a look. There we go. Okay, so we are mixing the gases, but only until we have enough in there. Okay, we don't have enough in there, but right, we do have more than 1 megapascals worth of pressure on the internals, so it will turn on now. Exactly. Very good. Okay, it is working. It is very slow, it is very intermittent, but I first wanted to make sure that it is actually working. Now I think we can play around with the different pressure values. So yeah. Okay. I will leave it here for now. And you will be filling up that pipe at nighttime. Okay. Well, we need to go inside and I will sort out the cooling in the next episode. All that is left to say is that thank you for watching. If you like the video, you can leave a like, leave a comment, and maybe subscribe to the channel if you want. If you would like to support me a little bit more, you can do so by clicking the join button and becoming a channel member, which will give you an early and ad-free access to these videos. Once again, thank you for watching and thank you very much for your support. I will see you in the next one. Thank you and goodbye.